Here are two solved gas problems. One uses the ideal gas law, the other one the combined gas law. What is the temperature of 2 moles of an ideal gas? It looks like we have an N there, right? They want you to find the temperature, so we could write that. They give you an N. I don't really know of hardly any gas formulas that involve N besides the ideal gas law. And ooh, they say ideal gas. I think this is going to be PV equals nRT. They give you a pressure, but the ideal gas law is very picky. It requires liters, atmospheres, mole, and Kelvin, or you could just say Latmolk to remember them all. So moles is good, but pressure we have converted to atmospheres, recognizing that 760 millimeters of mercury equals an atmosphere, and we have a little less than half than that. So that looks reasonable. We have 12 liters of volume. That is liters, so that's a good unit. And it's time to go ahead and solve it. They want temperature. I always just write the formula first. I rearrange for temperature, since that's what we want to solve for. So I divide both sides by nR. And then I plug in, making sure I'm using liters, atmosphere, mole, and Kelvin. Liters, atmosphere, mole, and solving for temperature Kelvin. They didn't ask for any kind of specific temperature unit, so Kelvin should be okay. And it's 45.5 Kelvin. Here's another problem. A gas has a temperature of 14 degrees Celsius. I don't like that temperature. I'm going to add 273 to it to get my new temperature of 287 Kelvin. Always do that for gases so you have a true indication of proportional temperatures. We have a volume of 4.5 liters. I do like those units. We're going to raise the temperature to 229 degrees C. Oh, it looks like we're doubling it and a little bit more, but of course not. When you convert it to Kelvin, it's only going up a little bit. The pressure is doubled, they tell you, to 2 atmospheres. This is no longer a ideal gas law problem, because those are always just fixed conditions. Here we have a T1 and a T2, so let's call that our both pressures. Notice that they didn't tell you the original pressure, but since it doubled, it must have been 1 atmosphere acute, right? And what is the new volume of the gas? I guess they want V2. Now, if you've done this, then you don't have to be told what the formula is. We have T's, V's, and P's. This is called the combined gas law problem, and there it is. Plug in all those units, but I personally like to rearrange first for V2, and I know I can get that by multiplying by both sides by T2 over P2. Do you get that? The T2 over T2 will cancel, and if the P2 is on the bottom, P2 over P2 will cancel. And that gives us the rearranged formula. I like that because now I just have all my ducks in a row, and I can put in my 5 numbers using the proper units, which I did. In other words, as long as they're similar, we don't care about anything except the Kelvin, and I got Kelvin. So solve it, and we find we have a final volume of 2.37 liters.